Now that we have seen what a control system looks like in abstract terms, a question is, are control systems actually useful? Do they have real practical applications? And my answer to these questions is that actually control systems, controllers, are so pervasive and so fundamental that we actually tend to take them for granted and forget that they exist, while actually they are virtually everywhere. So let me give you some examples. The first example is the autopilot in an aircraft. Now maybe you're a little too young to get the reference that I have here. This is Autopilot in the comedic movie Airplane by Mel Brooks from 1980. Autopilot in Airplane is an inflatable pilot that is capable of virtually nothing, but real autopilots in aircrafts are very sophisticated systems capable of combining, integrating, merging information coming from many sensors, and they're capable of sophisticated maneuvers, such as, for example, landing. So autopilots are definitely a kind of control systems that I think I'd say everybody who has ever traveled on an airplane has relied upon. But we don't need to be on an airplane. If we are just in our cars, we start seeing a lot of controllers. For example, one is the cruise control. Cruise control allows you to keep a constant speed while you're traveling. I hope that the cruise control in your car is a little more sophisticated than the cruise control that is depicted in this picture. But what a cruise control is nothing but a control system capable of keeping a constant speed that is your desired behavior. Another control system that is definitely in your car, or I hope it is the ABS system, the anti-lock braking system. It's a control system that monitors the speed at which your wheels, each one of them, is spinning, and it prevents each of the wheels in your car from locking. What happens when one of the wheels in your car locks? Well, first of all, first consequence is that your braking is not so efficient. So if you prevent all the wheels from locking, your braking takes less time and you are safer. But another reason why it's very important that your wheels don't lock is that if, for example, the wheels on one of your side, on, for example, the left side, the wheels on the left side lock, then your car can start spinning, and so that's definitely going to be very dangerous. So ABS is a very important safety system that is nothing but a controller. Now, controllers are not only in vehicles; they're also in our houses, everywhere. And I'd say the most pervasive example is the thermostat. We have thermostats everywhere. Thermostats are not only controlling the temperature of our rooms. You definitely have a thermostat in your fridge, you have another thermostat in your freezer, you have a thermostat in your oven. You also have a thermostat in your computer to prevent your CPU, your microprocessor, from overheating. So thermostats are again another simple control system that is capable of keeping the temperature constant. Again, in your house, you might think that you are enjoying the maximum of your privacy, but even there, there is a marvel of modern technology that is working for you, and this is the toilet tank. What is the toilet tank if not a control system that keeps the tank, that is designed to keep the tank always at the right level, almost full without overflowing. So the toilet tank is again a mechanical control system. And if that's not enough, I want you to know that controllers are inside us too. For example, the hormonal control system is just one of the control systems that are implemented in our body, and for example in this scheme that we're seeing how the thyroid gland is being controlled, we can see that there is a positive open loop here from the hypothalamus to the thyroid gland, represented by these plus signs, and then there is a negative feedback that the thyroid hormones provide to both the hypothalamus and the pituitary gland to make this system stable, and we'll see what we mean by stable definitely in this class. Let me also give you, since we have seen that that there are controllers virtually everywhere, but we haven't seen how they actually control, let me just give you an example of a very ingenious mechanism that was used to control the speed of steam engines. So James Watt, who's the inventor of the steam engine, adapted this controller that is called centrifugal governor to control the speed of a steam engine. So the principle is the following. Your steam engine is generating some torque, and the torque is used for something useful, but part of the torque is also sent to this controller. So when part of the torque is sent to this controller, so we have this system that is basically made of these two fly balls that start spinning at a speed that is proportional to the speed of the steam engine. When the speed increases, we see that these fly balls tend to be farther away, and they move this arm here that is connected to a valve. When the further apart they are, then the more this valve actually closes, so that less steam is applied to the cylinders of the engine. So the faster the engine moves, the less steam then is applied to the cylinders, making the engine slow down a bit. And if it's too slow, this valve actually tends to be open, and so more steam is given to the engine cylinders, so that the motor moves faster. So this is actually a very ingenious way, and it's purely mechanical, to control the speed of a steam engine to a desired set point. So we have seen all these controllers, and in particular we have seen how this controller, the centrifugal governor, works. So this is a purely mechanical device. Nowadays we tend to implement controllers using electronics, because in this way we can scale better their production. They tend to be more reliable, there are less moving parts, and also they can also be more sophisticated, because we can implement more sophisticated algorithms or policies using electronics. But overall, we have seen what controllers do. They are always based on measuring somehow the output of the system, and they are designed to modify the input in such a way that the system of interest behaves according to our desires.